Hello everyone, welcome to the class. So today, let's talk about the data representation in C program. Actually, we're going to talk about the data types in C. So what's the C data types and how to use it? And when we do the casting, how the C program actually do the casting. So let's look at the details. So if you remember in binary stuff, the binary word, we talk about how to represent the numbers in binary, right? So, but we also talk about the floating point. We also talk about the negative number. So how is actually do in your memory? How is actually do in your C? So actually, when we look at the numbers in the memory, it's 1111 this byte. What this means? Is this represent if it's positive number, it can be 255. Is 255 or it might be a negative number, negative one. We don't know. And even if it's a floating point number, how we represent it, right? Another case is okay. So in another the second one is a 65 in decimal, but it also can be in ASCII code value. Remember, it can be a in ASCII for value, right? So how when you have this sequence of binary numbers in your memory, and when your program try to look at this number, how your programs know they are positive number, negative number, or they are character. So actually, it's all about C data type. So C program is a data type programming languages. So you need to specific tell your compiler, your machine, your source code, what's the variable, what this means. It's a positive number, it's a negative number, or it's a character. It's a floating point, or it's maybe something else. So you need to specifically tell your compiler what this means. Otherwise, the machine just read the whole bunch of sequence binary number. It cannot identify is a positive number or negative number, right? Actually, we have a whole bunch of data type in C program, and depends on different machine, they will be represented in different way. So, for example, for just take this as an example, for this number, long number, uh, it's not double, it's not integer. For long number, in 32-bit machine, it's used 4 bytes to represent it. But in your 64-bit machine, it's used 8 bytes. Nowadays, most of our machine, they are 64-bit. But in the future, maybe you have a 125-bit machine. You don't know. You never know. And they will change it. They might change it. And it's all about the compiler, all about your machines, right? So usually we use 4 bytes to represent integer. We use 1 byte to represent a character. Because if you remember in the ASCII code table, 8 bit is enough to represent the English later stuff. Of course, if you want to represent in other languages, maybe you need more than one character. But basically, in English, one character is enough. 1 byte is enough for character. And there's another number called short. Short integer 2 byte, integer 4 byte. Long integer can be 4 byte, can be 8 byte, and double always 8 byte. And the pointers you might be familiar with, it's also different in different machine. For 64-bit machine, it's 8 byte, but for 32-bit machine, it's 4 byte. So it's all about instructions, the memory stuff. Okay, so you need to pay attention on this data representation. When you tell your machine, okay, this variable x is double, the machine will expect 16-bit. No, not 16-bit. A 8 byte, 8 bytes, which is 64-bit. 64-bit number, the byte number to represent this data. Okay, so you need to keep in mind there's something here, and of course, not just the integer, not just the long. You still have like unsigned and signed representation. You can use unsigned this keyword to represent an unsigned integer. Okay, so if you just use integer, it's a signed one. So you can use it to represent a negative number or positive number. But you can also make it an unsigned integer. If you make it unsigned, it's always a positive number. So if I give you a sequence of number 1, and I say integer tx equal to this 1, in this case, the tx is what? The tx is uh, actually integer is four bytes. So let's say 1, a lot of 1. So in this case, integer tx is actually just -1. But if you use unsigned equal to this 1, then the result will be different. It will be a big, really big number. It will be, I don't know, 232 minus 1. So this positive number will be in unsigned. So it depends on how you represent, how this number represent in your variable, how you define the type. It will show a different result. It will show a different result. Okay. So of course, when we do the casting we also need to take care of the signed and unsigned part. When we do tx equal integer ux, we convert the number from an unsigned one to a signed one. So a positive number can be a negative number when you do this casting. Okay, same thing here. If you do an unsigned, a negative number can be converted to a positive number for the first case. And if you do uy equal to unsigned ty, it can convert a negative number to a positive number. All about the bits and bytes stored in your memory. So the computer, they don't know this is positive or negative number. They just try to use a different way to represent, like to identify these numbers. Okay, so just keep in mind when you do this conversion, you might change your number from positive to negative or negative to positive if you don't pay attention enough. Okay, and also the most dangerous part is impulsive casting. Actually, the C languages allow you to do this. Even though you don't say, okay, I want to cast it to an integer, it also can support this part, this casting conversion. So you need to pay attention. You need to watch out what happened, what will be happen here. This is very important, like stuff you need to pay attention when you do this casting stuff. Sometimes you have a lot of variable. Some are on side, some are uh, like a side, just a regular integer. If you don't pay attention enough, you probably will mess up because the positive number can be changed to a negative number. It will cause a lot of problem, overflow problem, and some terrible things happen before. I remember there's a rocket stuff. They just they just blow out in the air. They cannot they try to go to the moon, but they do not because there's a very small overflowing part in the computation. So even this minor mistake can create that can crash like an airship ship, right? A spaceship. So try to pay attention on this stuff when you work on this. Okay, so here's the example shows when you do the like on-site sign conversion, when you try to do, for example, you want to get you have a short integer, you want to convert to an integer. You know, short integer is 2 bytes, integer is 4 bytes. How your systems automatically to convert these numbers? Okay, so in this case, you can see we have a short integers. Short integer is this number, -1, 2, 3, 4, 5. And we also have a one integer, no, on-site show integer here. This equal to sx. So -1, 2, 3, 4, 5 in the original format is like this. But you can see because it's a signed integer, so it's a signed short integer, right? So the first one is -1. And when we do this casting, we cast it to unsigned one. We just copy the value to unsigned one. This copy does not change any numbers, but because the numbers you try to use a different way to interpret it, so the number will become a really big positive number in this case. Okay, so we just copy this. We don't do anything. We just is impulsive cast it. We don't do anything. Then we got a positive number. even though the original number is -1. Okay, so this is about the casting. So how about the extension? If we want to make the number bigger, so from show integer to an integer, let's take a look of this example. So we have an integer x, which is 4 bytes, equal to this show integer, which is 2 bytes. So because this is signed integer, so the show integer negative number will give you still a negative number. So actually your C compiler understand this. If you have a negative number, it's a signed integer, show integer, you want to assign to a signed integer, then you will got something here. You will got one extension. Actually, what it actually do is just copy everything your most significant bit to here. So if it's a positive number, it will copy 0 and extend everything to 0. And because it's negative number, so you copy 1 and extend everything to 1. So this is still a negative number. No change, right? So when you do the extension from a show integer to an integer, because you copy the most significant bit, so you will still keep the same value, no problem. And this, for the unsigned integer, because it's unsigned, so it's used a different way. Let's take a look over. If we do the unsigned integer ux equal to this uxx, what it actually do is it will automatically fill in 0 because unsigned means it's always positive. So it's positive, I just give 0. No matter what's the most, what's this means. We don't care. Okay, so this is the difference between the extensions of a signed integer or signed value and unsigned value. If you do a signed value, it's use a most significant bit. Try to use this bit to fill in everything based on this. If it's unsigned one, no matter what the bit is, we just put 0 at the beginning. So this is the extension, about extension of your side extension and on-site extension. I hope this is clear enough. Okay. So also you need to pay attention on the evaluation. If you have a signed integer, unsigned integer, have an evaluation together, you need to know what part will you sign integer, what part will you use. So basically, in this case, if you have a one signed number and unsigned number, it will use unsigned number to evaluate. Actually, if you try to compare a signed number and unsigned number, it's always use unsigned one. So it will cast it. It will try to convert this one to a unsigned one, then do this comparison, got another value. Okay, so if you have a signed one, unsigned one, your compiler will automatically convert the signed value to unsigned one. Then use the unsigned one to compare the unsigned one. Okay, so this is something you need to pay attention. If you have a signed one plus unsigned one together, you will use unsigned evaluation. However, if you just use a signed one, compare signed one, then it will go with signed one. Okay, so pay attention if you use unsigned numbers, unsigned integers. If you use unsigned number, unsigned integers, then they will use unsigned evaluation. So this might give you a totally different result. For example, in this example, is -1 compared to 0, it should be should be true, right? It should be true if it's signed 1. But if you use the unsigned one, this one, unsigned one, this one compared to this one, it will be unsigned because -1 will become a really, really big positive number. The most significant number will be 1. So 1, blah, 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 definitely larger than 0. So it will be large. Okay, so you need to pay attention on this part too. Okay, that's it for today. I hope you enjoyed today's class. Today we talk about how this number represent in your C languages. Actually, we use type to like a control to manage these numbers because your computer cannot identify what this number means. It's a character, it's a integer, it's a show integer or something. So it cannot do it. So in this case, you need to manage this by yourself. And when you do some conversion, if you do the casting, just be careful because when you do a casting from an onside one to a side one or side one to an onside one, you might change the a positive number to a negative number. You need to pay attention on this part. Try to avoid the overfloating stuff, okay? And if you want to do some extension, for example, from a short integer to an integer, you also need to pay attention on what is it a side one or on side one. If it's side one, it's just use a most significant bit to extend the number to make the number bigger. So it won't change anything. But if you use onside one, it's just automatically fill in zero because onside one means it's positive, always positive. So it will fit zero at the top. Okay. So just keep in mind these details when you work on the program because it's like a tiny small like a mistake, a bug can cause a lot of problem, can cause a big gigantic like problems in the real world. Actually, it's happened before. So I hope you understand this. I hope this is helpful. Okay, so see you next time. Data representation in C languages is awesome.